Well, good evening, everyone, and thanks for coming. Welcome to Dome at Home. My name is Scott Young, and I'm the planetarium astronomer at the Manitoba Museum, and I'll be your host for this evening. We have a little bit of a technical glitch on our YouTube stream. We are live through Facebook, and we are live through our Zoom webinar, but unfortunately, it doesn't look like we're streaming to YouTube right now. We will get this posted up to YouTube. I know a lot of folks do watch our show after the fact, but unfortunately, those are our limitations for this evening. Hopefully, that won't be too much of a problem, though, and people will get a chance to watch it a little bit after anyway. All right, welcome to the show. It's great to be back for another week of Dome at Home. We'll be taking a look at the sky that we can see. We're finally getting into the position where we can see more planets than just Mars. So we'll be talking about those. In fact, right at the end of the show, you should be able to head outside and spot a couple of planets if you've got a clear sky off to the western horizon. We're also going to be looking at the mailbag. We got a whole bunch of mail coming in. We'll check in with Percy and Ginny, the Perseverance rover and the Ingenuity helicopter up there on Mars. And we're going to be touring the brightest stars in the sky. So that's our agenda for today. With me, as always, is Mike, who is moderating our chats and taking care of all the folks out in the various streams that we have out there. How's it going, Mike?
Yeah, I'm just catching up on everything because we got a little delayed getting in there. But yes, I'm great. Hello, everyone. It's good to see lots of regulars in our participant list, but also some new folks too. So welcome to those of you that have seen your first Dome at Home episode.
Yeah, excellent. It's nice to see new folks coming in. Of course, some of you have been with us every episode since the beginning, all the way back in January, and we love that. We love seeing you every week, and we love getting mail and so on. So let us know how you're using the show. If you're, watching it live, if it's inspiring you to actually go out and look at the real sky, or to find other content online to do with astronomy and space and things like that. I love seeing that kind of stuff, and it really brings a warm feeling when we know that this is actually making a difference for some people. And as far as the mailbag, we got a message from one of our friends. Ulrich out there was observing with his binoculars, and he's written in a couple of times talking about the things that he's been able to spot with his binoculars. And actually, we've had a number of people ask us for things that they can look at with their binoculars, because you might not have a telescope yet, but many people already have some kind of binoculars in the house, perhaps, or access to. They're a little bit easier to find right now. You can still actually buy them, whereas telescopes are still pretty hard to come by. Maybe this month, we hope. So we are going to add some more binocular content into our program. And for those of you that are the binocular aficionados, we're running a special 2-hour workshop called Stargazing with Binoculars. And I'll be teaching that on June the 13th, which is, I think, a Sunday during the afternoon. And then we're going to repeat the course for people that would prefer an evening slot on Tuesday, June the 15th. So you can get the details for that on the Manitoba Museum's website under programs and events. So the details are up there. And so that's coming up, and that'll be a 2-hour detailed look at how to use your binoculars to find things in the sky, what you can see, where to look, and some sort of tips and tricks from experienced observers. Now, speaking of programs and events, coming up, it's Manitoba Day. May the 12th is Manitoba Day officially, and that's always a big deal for us down at the museum. It's we have all sorts of special programs. I mean, the Manitoba Museum, Manitoba Day, it's kind of our thing. And this year, only the museum has the ability to be open right now. The Planetarium and Science Gallery are still closed. And so we're doing a bunch of virtual online activities. And again, you can find all this on our website. There's a whole bunch of content that will allow you to engage with Manitoba Week, as we're calling it. So on May the 12th itself, we have a virtual field trip. There's a scavenger hunt activity that you can do. We have a really excellent program with some music that's coming through. And then on May the 15th, which is the event that I know the most about, that's also International Astronomy Day. And so we will be doing a special telescope event on May the 15th. And so you can join into that, and we'll look at a bunch of the planets and the moon and things like that, either from telescopes here in Manitoba, or if it's cloudy, from telescopes elsewhere across Canada. Now, the great thing about Manitoba Week is that if you, as you know, you can watch us on social media, Facebook and YouTube, but you can also register directly for the Zoom webinar, and that's where you can get in on the chats and things like that. Everybody that does that is automatically registered to win some prizes, some passes to the museum. So if you join us for one of those through Zoom, sign up for that. You'll be able to get registered automatically to win some museum passes. So that'll be fun. I'm looking forward to that. It's always a great time to do Manitoba Day related things and celebrate our province. Okay, let's see. I see a number of questions have gone by. My chat window disappeared. Okay, there we go. Okay. So let's see. In terms of other mail, we do have a few other things that have come in. We've got some great questions from Oakenwald School, and there were so many questions that came in from your school that we wanted to make sure that we can answer them all properly. So Mike and I have come up with a plan of how we're going to spread those out over the next number of episodes, and so we'll be answering those questions in the Q&A session at the end of each section. So we'll be weaving those into the questions that we also get live from the various audiences. So you can watch for that, Oakenwald School. And interestingly, many of the same questions that come in from Oakenwald are the similar kinds of questions that we're getting live. So, oh, Lucy, you're one of the folks from Oakenwald. You wrote one of them. Excellent. Yes. Oh, and I just saw Phil going asking here in Zoom, know anything about the May eclipse? Yes, we will talk about the May eclipse. It's going to be more of a feature of next week's show. There's a lunar eclipse that we can see a little bit from Manitoba, and so we'll be talking about that. It's May the 26th, I think, is the date. So we'll be getting to that in the next show. So you've got a little bit of time for that one. All right, let's move on to Skywatch. We'll get our sky going here. There we go. And so, your evening sky, this is basically the sky as it is right now. The sun sets a little bit before 8 o'clock tonight from here in Winnipeg. And if we just jump forward an hour or so, right after the sun goes down, as soon as it starts getting dark, some stars start to become visible in the evening, very, very low. Now you'll notice the view that we've got here, the horizon is pretty clear. We don't have a lot of trees or buildings or things like that. You really need to get a good horizon to be able to spot these things right now. But if you have a clear horizon, look out towards the west-northwest, around about 8:15 or so, and you'll spot a very bright star quite low on the horizon, and then fainter but higher up, a second pretty bright star. Well, those are two of the planets of the solar system. The brightest one here, this is Venus. Venus is just coming around from the far side of the sun. And so over the next number of weeks, it will be rising a little higher in the sky as it moves farther away from the sun. We talked a little bit about how the planets move around last week and how they get, towards their elongations, the distances away from the sun. This other object up here, this is Mercury. And Mercury is actually already pretty far from the sun. It'll get a little bit better over the next week or so, but this is the best time of the year to spot Mercury. Usually Mercury is either so close to the sun you can't see it, or it might be far away from the sun, but the angles are just not perfect to get it up above the horizon. Right now, for the next 2-3 weeks, this is the time to see Mercury. So get out there right after the sun goes down. Venus will probably become visible to your unaided eye. Mercury, probably you'll be able to see it, but it'll depend exactly on how good your eyes are, how clear the sky is and stuff like that. If you have binoculars are a perfect aid for your eyes to do things like spot the planet Mercury. And so over the next couple of weeks, you'll see these planets change their back and forth positions as they both slowly orbit around the sun. Now you'll notice this is the sky about 8:15. If I advance forward one more hour, here it is 9:15. The sky's now started to get dark, but those things have set. So Venus and Mercury, they disappear pretty soon after the sun. So you really have to catch them in that sunset kind of period. Let us just zoom out a little bit here. There we go. So our western sky, Orion is now pretty much gone. You pretty much are not going to see Orion very much at all. You might catch one or two of the brighter stars just as it's setting into the west, but really those stars have disappeared. Mars, however, is still up there. There's the planet Mars in the feet of Gemini, the twins. It really has faded. It's really going around the far side of the sun right now. And so it's at its sort of smallest and faintest from our point of view. Still hanging on there in the evening sky, though. And of course, the constellation of Gemini, we featured that a few weeks back. These two bright stars, Castor and Pollux, we'll be visiting them later as we tour our brightest stars of the sky. Let's zoom out a little bit and we'll move off towards the south. The southern sky, again, no major changes at this point. We've got Leo the lion over here. We've got Virgo the maiden over here that we've talked about. And up here, the ice cream cone shape of Boötes the herdsman. The brightest stars in each of those constellations we'll also be visiting later as part of our brightest stars tour. But nothing really has changed too much here. Over in the eastern sky, we still have those summer constellations starting to rise up. Hercules over here with the Hercules star cluster right in about there that we talked about. That's what Ulrich was able to find with his binoculars. We've got Vega coming up over here, the first star of the summer triangle. And as the night goes on, all of these stars in the east will slowly rise up higher and higher, and that'll give us, a better and better view. There we go. And finally, up into the north, we have, again, same kinds of stars. The Big Dipper still high overhead this time of the year. The two pointer stars in the bowl of the Big Dipper point back towards the North Star. There's our North Star Polaris, and that's the constant star that stays in the one spot while the whole wheel of the sky spins around it. So the constellations haven't changed all that much. The real new thing is the appearance of Mercury and Venus in the evening sky. The moon is heading towards, new moon is going to be in not all that long. And so that basically means that the moon is pretty much out of the sky until the early morning hours. So we're getting into the time when the sky doesn't have moonlight interfering in the evening. So once it actually gets dark, you can go out of the city, drive away from those city lights and not have the moonlight interfering, and you can get some really dark skies. And that's where you can really see the fainter stars. You can see some of the Milky Way, for example. You can see some of the fainter stars that make up the constellations that maybe are a little harder to pick out in the city. And if you have binoculars or a telescope, that's really the time to get out and look for some of these star clusters and all that kind of stuff. So that's our sky right now. And as I said, we will be touring the some of those brighter stars in just a moment. Let's see here. There we go. Sorry, I keep seeing messages popping up from my streaming service telling me that it's still trying to connect to YouTube, and it's not. So I don't think we have a YouTube stream right now, but we'll upload that video later. Okay, so we've talked about the brighter stars that you can see from inside the city. Sometimes you can't see the fainter ones, but the brighter ones are usually visible even from downtown. And as long as you don't have a physical building in the way, you can see them. Well, what are these brighter stars like? We know that our sun is a star, and that's the one that we're closest to. It's, very important to our solar system. We're going to use that as our comparison and take a look at some of these other stars that are out there. So we're going to start actually over in the west. We'll catch a couple of the winter stars before they disappear. We've got our constellation of Castor and our constellation of Gemini, the twins, pardon me. We'll zoom in a little bit here. This actually does kind of look like, if you imagine these two stars are the heads of the twins, and then they're kind of like stick figures holding holding their arms around each other or something like that. Kind of looks like a couple of people. There's Mars again. So these two stars at the top here, this one is called Castor on the right, and this one is called Pollux. That's the name of the two twins in Greek mythology. Each of those stars is a sun. And then of course, we can't see them as anything other than points, but by analyzing the starlight, by doing a whole bunch of complicated science, we can basically figure out what those stars are like compared to our sun. And so let's take a look at this star here. Actually, we'll start with this one. This is Pollux. Pollux is the brightest star in Gemini. And if we compare it to our sun, this is basically what we have. Here's our sun, a nice yellow ball, about 1 million kilometers across or so. Pollux is much, much larger than that. And it's not a yellow star. It's sort of an orange giant. Pollux is basically a giant star. And it's about, what are we at here? Yeah, about 8 times as big as our sun. So you normally don't see that kind of color when you just look at the star in the sky. When we're just looking at, the map up here, it's going to look mostly white. You might notice a slight orangey yellow hue, but really the colors are pretty subtle. But if you were in a planet going around that star, you would absolutely know that it was an orange giant star. Right next to Pollux, the other star, is Castor. Castor is a very different system. Castor is made of 6 stars, all in orbit around each other. Phil just jumped in saying, yeah, Castor is 6 stars. So when we name stars, when they look at a star with a telescope and they say, oh, look, there's 2 stars there, we name them really poetic names like Castor A and Castor B, and then Castor C. And then when more powerful telescopes are invented or other kinds of methods tell us that each of those stars is actually a pair of stars that we just couldn't resolve before, they were just too close together to see, they start with different letters. They go Castor capital A, Castor capital A, little b, and so on. So it's kind of a confusing system that just it's because basically we discover these things piecemeal. It's not like somebody really was able to see everything all at once. You make these discoveries, someone sees that Castor is actually 2 stars, and so they call them A and B. And then someone later down the road discovers the 3rd star, and so you have to add it into the existing system. And yeah, astronomers, they're not the most poetic type. Lucy points out, very poetic. Astronomers are horrible at naming things. Absolutely horrible. We have, spots on the sun, sunspots. We have, letters and numbers for things. We have, there are a few good names. The solar system got names that were sort of well thought out. And now we're at the point where things are discovered so quickly, a lot of things don't even get names at all. And they just get the numbers that they were assigned. So pretty difficult to keep up with naming everything. But the thing about Castor is that Castor A, the big blue star, has a little red dwarf that orbits it, and quite close. And then Castor B has a little red dwarf that orbits around it. And then Castor A and Castor B orbit each other. And then orbiting all of those is this, oops, I hate the scroll wheel on my mouse. There we go. Orbiting all of those is this little pair of red dwarfs called Castor C. So quite a complicated system, not at all the kind of place you would expect to find planets, because, if there were planets going around one of those stars, the gravity of all the other stars would constantly be pulling on them in different directions, and you would just not have stable orbits for planets. So generally, when you have multiple stars like this, probably not planets. However, not a hard and fast rule. Okay. Back to our sky here. We've got right next to Gemini, we have Auriga, the charioteer, and the brightest star there is called Capella. Capella is a bright white star to our eyes. It's something that never quite sets for us. It just skims along the northern horizon. So, even in the summertime, you'll see Capella shining very, very low in the north. It's usually flashing different colors because of the turbulence of our atmosphere and things like that. We often get it reported as a UFO or whatever. It's obviously it's not a UFO, but it is again a multiple star system. In this case, 4 stars, and the 2 primary ones are much, much bigger than our star. Similar in color, similar in temperature. The color and the temperature are very much linked. So both of these stars are about the same temperature or a little hotter than our sun is, but they're obviously also much bigger. So they put out a lot more energy. There are so many stars in the background around Capella that people would discover new companions, and then it would turn out after analyzing them, those stars were actually just way off in the background. They just happened to be lined up from our line of sight, but they weren't really attached. That's why you don't have Capella B and C. They got all the way to H before they actually got one star that was actually gravitationally bound and orbiting around these other ones. And then all the way down to L too, this tiny little red dwarf that orbits around. So there's 4 stars that we just can't split from the Earth here. Okay. Wanted to do a couple of those winter ones just because the winter constellations, they're still sticking around there. We'll go back over to our southern sky. We've got Leo the Lion that we've talked about a number of times. Leo is got the very bright star Regulus at the bottom. Regulus means the little king, and this is a star that has always been associated with kingship. It has a variety of stories that go back thousands of years from many cultures relating it to that, probably because it is on, it's very close to what we call the ecliptic, that path where the planets go. So basically all the planets at some point, they all pass by Regulus. In fact, sometimes they even get so close to it that they look like they merge with it. So it's in a pretty important part of the sky. I imagine that's why it is. Well, nowadays we know that Regulus is made up of a giant blue football. Regulus, the primary star, is very, very big. It's very hot, much hotter than our sun, like 10 times as hot as our sun. And that means its temperature is like blue-white, just as hot as, almost as hot as you can get. It's orbited by a tiny little white dwarf. I had to put an arrow there because I wasn't sure you'd be able to see it when I put it to the right scale. A white dwarf is probably the center part of a star that died already. So maybe a star even bigger than Regulus A that has run out of fuel, died, and all that's left is the core of the star, the white dwarf. And then, and again, another couple of these red dwarf stars that go around it. So Regulus A is shaped like a football because it's spinning, just like all the stars. In fact, our sun spins around. It takes about 27 days for the sun to, for our sun to orbit around once, which is a fairly reasonable kind of path. The star Regulus A only takes 16 hours to go around. And if you look at the size, it's got a much bigger distance to go as well. So it's spinning so fast that it starts to flatten out into this elongated football kind of shape. That's something that had no idea in terms of this is something that stars could do. But because it's spinning so fast, it's like it's almost like it's made of Jello. If you put a big ball of Jello and you spun it around, it would start to sort of bulge out. And eventually, if you spun it fast enough, yeah, like Saturn, Phil says, if you spun it fast enough, it would just fly apart. There wouldn't be enough energy to keep it all together, and it would fall apart. Regulus is at 97% of the speed that it needs to fly apart. So it's so close to the limit that Regulus might one day just tear itself apart, which would be kind of cool to watch. You know, like pizza dough. That's a good analogy, Lucy, sorry. When you're, when the chef is like tossing the pizza dough and then spinning it around and it starts to spin and flatten out. That's a perfect analogy. Great job. Okay, we got a couple of other stars here. I wanted to do Spica. Oh, sorry, Arcturus. Arcturus, that's the star in the ice cream cone of Boötes the herdsman. Arcturus is a red giant star. It's 27 times as big as our sun, radius-wise, so I couldn't even fit it onto here. Originally, I I'd shrunk everything down, but then I would have had to change the size of the sun. So all these pictures have been at the same scale, basically, using the same reference size of the sun. Just a massive, massive star. And it is a single star, but what's cool is we think Arcturus might have a planet going around it. We're not 100% sure, but it's very possible that Arcturus has at least one planet going around it, which is kind of cool. Spica is two footballs going around each other. They're both spinning so fast that they're going out like that, and they're so close together that the football edges are almost coming together. These two stars are spinning around so quickly, it's entirely possible that they're in the process of merging, or maybe they're going to transfer material from one to the other. There's all sorts of really interesting things that happen to stars when they spin that fast. And so that's something that's going on in the night sky. You can go out and see Spica. It's one of the brighter stars in the sky. It's right down over here in the south in the constellation of Virgo. And that's what's going on with it. It's this very complicated system. Now, we could do this for all of the stars, obviously. Each star system is going to be different on its own. I wanted to do one more star, though, that maybe isn't one of the brightest ones, but is probably one of the more interesting ones. Polaris, our North Star. It is, always there in the north, stays in one spot. That's just a coincidence of its position in the sky, though. It's not anything to do with us, basically. It's just a fluke. But when we look at Polaris, we see that Polaris is actually a very complicated set of suns as well. So the main star Polaris is the biggest star that we've come across so far. This is 35 times the sun's diameter. It's basically a star. It's like what our star will perhaps turn into a few billion years in the future. It's also what we call a variable star, a star that changes. Polaris actually gets bigger and smaller when as it sort of pulsates. The energy on the inside sort of makes it bubble up and get a little bit bigger. But as it gets bigger, it cools off. And that means the cool stuff sort of sinks back down. And you get this sort of almost like the star is breathing back and forth every 4 days or so. It's not a amount of brightness that is noticeable to the average person, but you can actually detect it with scientific instruments. And then going around Polaris, there's another couple of quite hot sun-like stars as well. So a triple star system in the north. Now we had a question here. Ulrich was asking, how do we know the difference between star-star versus star-planet? Well, a star is big enough that it can create enough pressure in its core that nuclear reactions can happen. Basically, it lights up and it starts giving off its own energy. A planet is smaller than that. It doesn't have the weight or the material to crunch down the core enough to turn on those star reactions. There might still be some heat on the inside, but it's not enough to actually turn it into a star. So basically, that's the difference between a star and a planet. And Melissa's asking the difference between sun or star. We used to say that our sun is the sun, and then the other stars are stars. Once we realized that our sun is a star, it's perfectly legitimate to call the other stars suns as well. As long as you sort of clarify when you're talking about our sun, the one that our planets go around, and other stars that are out there that might have their own solar systems. I like to remind people that the other stars out there at night are suns, because that sort of reminds you that, there might be planets going around them. There might be all sorts of interesting things happening, just like there are happening around our sun. Okay, let's see. There's a bunch more stuff we could do about stars, but I think I'll save a couple of them for the next thing, because now it is time for
Cool Space Stuff!
Okay, we talked last week, the new Chinese space station was launched, and the orbit is such that we can barely catch a glimpse of it from here in Manitoba. You have to be a little bit farther south to get a good view of it. You can actually see it about once a night in the early morning right now from southern Manitoba. And you can visit the Manitoba Museum's website And in the planetarium section, there's a link to Heavens Above, which calculates all the times for things like that. The good thing is that there's a new space station up there. The bad thing is that the rocket that was used is still up there and is going to come down. And so we've been tracking the booster rocket. That's basically, let's see, that's this section here of the giant rocket that they used to launch the space station is going to fall out of the sky sometime around May the 9th, plus or minus 16 hours. They're tracking it, and basically it's up high enough that it goes around the Earth, but as it goes around the Earth, there's still enough atmosphere up there that it starts to slow it down, and eventually it starts to spiral in, and eventually it will re-enter the atmosphere and come down into the Earth. So this happens all the time with rocket boosters and satellites and things like that, but usually they're either done on purpose, like for example, SpaceX, they go up, they launch their thing, and then their rocket comes down and lands. Other ones that don't land, they at least plan for them to land in the ocean or something like that. This booster rocket is so large, and the space station that it launched was so large that they just couldn't control its reentry. So it's going to fall back a little bit at random. So we see a few things in the comments here. We're not going to die. It turns out that you're pretty small compared to the size of the entire Earth. And this rocket, they're trying to refine where it's going to land. But the last time this happened, about a year ago, almost all of the rocket burnt up on reentry, and all that came down were a few pieces. But even still, that's enough to be worried about. This really shouldn't be happening. We should be at this point able to clean up our mess after launching stuff into space. Unfortunately, that wasn't the case this time around. So we're going to be tracking that. Probably by the next show, I'll be able to tell you exactly where it came down, and probably in the middle of the ocean or something like that. But if you want to keep in touch with that, you can always join the Facebook page, or you can follow me, Scott the Skywatcher, on Facebook. I tend to update that just because people like to know when stuff falls out of the sky. Checking in with Ginny on Mars. This is flight number 4, and they finally got enough data back to show the view from the helicopter as it flew across the Martian surface. So the two slightly moving things, those are the rotors, and it turns out that the camera is taking pictures at exactly the same speed or exactly the same frequency that those rotors are going around. It looks like they're hardly moving. In actual fact, they rotate 21 times between each picture. And this is in real time. So you can get a sense of how fast those things are actually spinning. So this flight was number 4, and they have now decided that they're going to move to a new area, set up a new airfield for the next flight, and really start to do not just look, can we fly around, but starting to do some of the things that you want to do with a drone in terms of, scouting for new areas or doing science or things like that. I just think it's super cool to see all these things as they come down. These images came down, basically, you could see them at the same time that the actual engineers at NASA could see them, and it was pretty exciting. Let's see here. Okay. I think we have a little bit of time for questions, and I saw a bunch of them go by there as we got into the thing. Mike, do you want to parse some of the questions for us, and we'll get into a few of those before we wrap our show?
Ooh, yeah, there's been a lot, so I'm going to apologize to folks. We're not going to be able to get to all of these. I'm going to try to stick with the ones that related to tonight's topics. Let's start with a good question about stars and why they appear mostly white to us in our sky, as opposed to the vastly different colors that they are in close up.
Yeah, that's a great question. So it turns out that our eyes have 2 different kinds of vision. We have basically our daytime vision, which is designed for walking around in the daytime, and that's where our color vision is. We also have some night vision, but in order to see things when there's not very much light, our eyes basically turn off the color and go to black and white because that's more sensitive. So when there's lots of light, you can see color. But when it's dark, you only see things in black and white. And what that means is stars are just not bright enough to make our eyes see the colors very easily. If you can make the stars look brighter, though, you can see those colors better. For example, if you use binoculars, that brings in more light, makes the image brighter, and you can see the colors of the stars a little easier. Same thing with a telescope. And I mean, really the same thing with a camera. When the camera can take an exposure and record the light for a few seconds, it can really show the colors very, very nicely. Our eyes just aren't designed for that kind of viewing, though. And so we don't always see the colors as much as we'd like to. Good question.
Yeah, very good question. I'm going to combine a couple of questions into one because they are very related to one another. Do all stars spin in the same direction, like clockwise or counterclockwise? And does a star's rotation ever slow down or change throughout time?
Good questions. Well, the answers are complicated, but so the first part, do they all spin clockwise or counterclockwise? Kind of doesn't matter, because if you were to look at it from the other side, like there's no up or down in space really, so you can sort of look at it from whichever way you want, and the stars will all spin, in a particular direction. So it's not so much clockwise or counterclockwise, but all the stars basically have a single direction of spin like that. The slowing down, yes, stars absolutely can have their rotation slow down or speed up, especially when they're in multiple star systems. The gravity of another nearby star can really mess with a star's rotation, and all sorts of interesting things can happen. But they happen over really long time periods. It's not something that happens, in a single human lifetime. Stars are around for billions of years, so 50, 100, 200 years still, that's not much time for a star.
Okay, let's switch over a couple of questions about the Chinese booster that's going to come down. And a good question, which I kind of know the answer to, but I just want to see your take on it. What is the protocol if some pieces of said rocket were to land in a populated area?
Run! No, just kidding. Yeah, I knew that. You knew that's where I was going. Hey,
Yep.
Yeah, it's one of those things that you almost aren't going to know that it's where exactly it's going to come down until it's already re-entering. We can make a prediction that somewhere along a certain path you'll be able to expect that it might come down. Here, I'll just switch over to the image here. Hopefully this will work. It's not. Okay. I was hoping that I could get the map up here. But basically, you wind up having a whole bunch of paths that the satellite could come down in, like, over its orbit. And right now, it only takes the satellite about 90 minutes to go around the Earth, and they're plus or minus 16 hours. So really, it could come down anywhere that it goes over top of, which for this particular booster is from plus 41 degrees latitude to minus 41 degrees latitude. So that's a significant, there we go. That's a significant area of the populated world, like a huge amount. Let's see if we can move this over a little bit. There we go. That's not what I wanted to do. So yeah, you wind up with this fairly complicated map here. There we go. We'll just pull this over manually. All of those lines indicate where the satellite is traveling over the course of 6 hours. So any place underneath any of those lines on the world map is technically still in the target area right now. However, as we get closer to the date, that uncertainty will come down, and eventually they'll be able to say, oh, okay, here's the rough region. Right now, the forecast has it over sort of the Middle East area near the Red Sea going into Saudi Arabia. Although frankly, 2 hours ago, it was in Australia, was the predicted impact. And just before that, it was off in the Pacific Ocean. So by about probably tomorrow evening, maybe Saturday morning, we should know a little bit more. But it's one of those things that when it happens, and there's really nothing that anyone can do about it.
A very interesting question from Lucy. Do I own pieces of the spacecraft if they land in my private property?
Well, that's an interesting question. The international treaties that govern such things basically say that a spacecraft belongs to the sovereign nation that launched it, even after it comes down onto the ground. Now, they're very keen to come and pick up those pieces if they don't hurt anybody, but you can bet that if a piece fell and dented your car or something like that, they would be very quick to say, no, it's not our problem. There really isn't a whole lot of precedent in terms of legal cases involving outer space stuff. So it's a little bit confusing. I'm pretty sure, though, that no one is going to come from China, 5,000 kilometers around to pick up a little piece of metal or something that made it down. So I wouldn't worry too much about it.
But a good point to make, though, is that like some of these pieces could actually be somewhat dangerous in themselves. I mean, this is a booster rocket. It used fuel to boost something into space. I know that back when Columbia broke up in the atmosphere over Texas back in 2003, they were warning people that, this, don't touch it for obvious reasons, but also because there could be a risk to injury and health. So a very important thing. I mean, I get Lucy's question. It was a bit of a joke question, I think, but it's on a serious note, it probably shouldn't be touched. What do I want to go to next here? Lou was just asking, will the booster be seen as a falling star?
Well, that's the plus side of this. Right now, the booster is actually visible as a satellite in the sky, just the same way any satellite would be. And as it gets lower and lower, it'll be moving faster and faster. When it goes into the atmosphere, it will basically burn up like a slow motion shooting star. If you were lucky enough to have it happen close to you, but not like right over your head, you would basically see this ball of fire that would slow motion move across the sky and break up into a whole bunch of pieces and fragment. Beautiful, beautiful sight, like an amazing fireball or shooting star, but in slow motion. Having said that, you don't want a really close-up view, but a nice distant view would actually be pretty darn impressive.
I think so, yeah. We'll go back to stars for a second, because Vivian asked a really good question. We talked a lot about red stars and blue stars and yellow stars, but she was pointing out you never really hear of purple and green stars. Why is that?
Yeah, so that's an interesting question. So there are purple stars and green stars, although generally, well, I'll get to that. The star's color is related to its temperature, and basically when something is what we call red hot, you get that sort of red orange color. As something gets hotter and hotter, it goes from red through orange through yellow, and then eventually up into blue or white, and then blue white. The colors of green and purple and things like that, those are sort of compound colors that are usually a mix of more than one color. They're not usually straight from something that is hot and giving off energy. So that's why we talk about individual stars that way, and you don't hear about green or purple or things like that. But when you're looking at double stars, when you're looking at the stars like we saw with multiple star systems, when you look at things with your eye, color isn't just an absolute scientific term. Color is a perception. And when you've probably seen those optical illusions where you have like a red dot and a blue dot, and one of them looks like it's closer than the other or bigger than the other. Our brain does interesting things when there's different colors around. And so when you look at some of these double stars, some of the early observers have these wonderfully poetic versions of, a amethyst purple star next to a golden yellow hue or things like that. And there is a whole range of colors that you can see with these stars. Many of them are our eyes sort of just comparing and contrasting them, but still they're very real, very beautiful. And some of those, I would say like the 17th, 18th, 19th century observers would often record those colors in exquisite and somewhat poetic detail.
Okay. I'm seeing a lot of comments saying that I'm echoing. I apologize for that. I can't hear it on my end. Scott, I don't know if you...
Yeah, no, I don't hear it either.
But I'm getting it from Facebook and Zoom, so But
Okay.
anyway, we're nearing the end of the show. Anyways, let's end things off with this really fun question. Have you ever discovered a star?
Well, yes, I have. I've discovered many things in my astronomical career. I discovered the moons of Jupiter when I was about 14 through my friend's telescope. We had no idea what it was going to look like, and we saw these things, and it was like amazing. Now, I know Galileo beat me to it by about 400 years. He discovered them first, but that didn't lessen my sense of discovery. I still made that discovery, even though somebody else got the credit for it. I still felt the same way. And that's what I love about astronomy. Every time you go out and you discover something or you see something new, it is really a sense of discovery. I do not have an independent first-person discovery that I've made yet. Most of my astronomy research is not sort of discovery based, although I do have a small asteroid search program. And so I hope one day that I will discover an asteroid, but I haven't yet. So
maybe one day.
One day. Yeah, exactly. In all my free time.
There you go.
Okay. Well, it looks like we've come to the end of our show. So thank you all for joining us. We will get this uploaded to YouTube as quickly as we can so that the folks on there can get to us as well. It looks like it's going to be clear tonight. In about half an hour, go out and look for Mercury and Venus off to the west. And you can also see Jupiter and Saturn in the early morning sky as well. For all the details, you can visit the website and check out all of the things that we can see in May's skies through the Manitoba Museum's website. And as always, you can reach us through Facebook or YouTube or through email at space@manitobamuseum.ca. Thanks for joining us, and I hope you have a great week, clear skies, and we'll see you again next time.